page 86 to 87 of Unit 3, Rules for Differentiation, Finding the Derivative of a Composite Function. So first thing I'd like you to do is to rewrite the function f of x equals 2x plus 3 quantity cubed as a function in polynomial form, and then find the derivative of f of x. So I'm going to start you off with the first step, right? So we want f of x equals 2x plus 3 cubed. So we're multiplying it by itself 3 times. Okay, so I want you to actually multiply those out and then find the derivative. Leibniz was the first of the two great calculus developers to use the chain rule to differentiate composite functions. So we're going to write this rule together in the box. So if h of x is equal to f of x equal to f of g of x, right? So a composite function has a function within a function. Then h prime of x equal to f prime of g of x times g prime of x. Okay, so if you think of it as, a lot of the students last year like to call this the baby mama rule, right? So this is a mother, this is a pregnant mom, right? So if you have a pregnant mom, then the derivative of that pregnant mom is the derivative of mom with baby times the derivative of the baby. Okay, another way to think of this is the inner and outer function. So the derivative of h prime would be considered the derivative of the outer function times the derivative of the inner function. Okay, so we're going to use that information to find the derivative of f of x that you did above, but now we're going to find it using the chain rule. Okay, so if I have f of x equals 2x plus 3 cubed, right? So in this case, the outer function for the mom is x cubed, and the inner function, the baby, is 2x plus 3, right? So the derivative of the outer is equal to 3x squared, and the derivative of the inner is equal to just 2. Okay, so if we look at our chain rule, f prime of x will be equal to the derivative of the mom, which is the outer function, the derivative of the outer function, with the baby. So when we see x in the derivative, we're going to plug in the baby. Okay, so we'll have 3 2x squared. And we're going to multiply that by the inner function, the derivative of the inner function, which is 2. So when we simplify this, we have 6 times 2x plus 3 squared. 2x plus 3 squared is 4x squared plus 12x is 9. And that times 6 is equal to 24x squared plus 72x plus 54, which is what you should have gotten above. So we're going to try this again with another problem, and we have plenty of problems on page 87 as well. So we want to find the slope of the normal line to the graph of f theta equals sine squared theta, where theta is equal to 3 pi over 4. Okay, so we're going to rewrite f of theta to look more like a chain rule problem. So we have sine theta squared. So our outer function is x squared. Our inner function is sine theta. So the derivative of our outer function is 2x, and the derivative of our inner function is cosine theta. So f prime of theta will be equal to our pregnant mama. So here's our mama, the outside function. And since it's pregnant with our baby, we want to substitute the inner function in for x. So we'll have, instead of x, we'll have sine theta. So 2 times sine theta times, and then the derivative of our inner function is cosine. So we'll have 2 sine theta cosine theta. And we want the derivative of 3 pi over 4. We'll put that in for theta. So 2 sine 3 pi over 4 cosine 3 pi over 4, which is 2 times root 2 over 2 times negative root 2 over 2. The 2's will cancel here, and we're left with root 2, sorry, we're left with root 2 times root 2 over 2 negative, which is just negative 2 over 2, which is just negative 1. So that is the slope of the tangent, and we want the slope of the normal, so opposite reciprocal will just be 1. Okay, so let's do a few problems from page 87. All right, we're going to do just 3 problems on this page. So, first problem we're going to do on this page is g of x from the first row. So we're going to rewrite g of x so that we can see the chain rule, right? So we have an inner function and an outer function. Our inner function actually, let's start with our outer function. So our outer function is x to the 1/2. Our inner function is 2x plus 5. The derivative of our outer function is 1/2 x to the negative 1/2, which is also just 1 over 2 root x. And our derivative of our inner function is just 2. You can also simplify the derivative of our outer function to the square root of x over 2x. So to find g prime of x, we need our mama, which is our outer function, and our mama needs to be pregnant. So every time we see x, we're going to plug in our inner function. Okay, so we'll have our outer function, which is x, which is 1/2. Instead of x, sorry. So we'll have the square root of, instead of x, we'll have 2x plus 5 over 2 times 2x plus 5, all times the derivative of our inner function, which is just 2. So g prime of x equal to 2 root 2x plus 5 all over 4x plus 10. Which is simplified to just root 2x plus 5 over 2x plus 5. Okay. The next problem that we're going to do is problem number 4, I guess you would call it, which is the capital F of x. So capital F of x, I'm going to rewrite it 5x squared plus 2x to the 1/3. So the inner function, actually, let's just start with the outer function. So the outer function is 5x to the 1/3. The inner function is x squared plus 2x. The derivative of the outer function is 5 over 3 x to the negative 2/3, which is equal to negative 5 over 3 cubed root of x squared. Which I can rewrite once more as negative 5 cubed root of x squared over 3x squared. And the derivative of our inner function equal to 2x plus 2. Right, so then to write the derivative of capital F of x, we need the pregnant mother. So everywhere we see x, we're plugging in our inner function. So we'll have negative 5 cubed root of x squared plus 2x squared, all that squared, over 3 times x squared plus 2x squared. All of that times, use a different color, 2x plus 2. So when we simplify that, we get -5 times 2x plus 2 times the cubed root of x squared plus 2x to the 4th, really, because the squared and squared, all over 3 times x squared plus 2x squared. We can simplify this even more to being -10x minus 10 cubed root of x squared plus 2x to the 4th all over 3x squared plus 2x squared. All right. Now the last problem that we're going to do is h of x on our last row. The reason why we're going to do this problem is because it is a multiple chain rule problem. Okay, so we're going to rewrite h of x so that we can see the chain rule. So we have sine 2x plus 1 squared. Okay, so we have two inner functions in this problem. So we need to figure out how many generations of mamas and babies are we going to have. Okay, so our really inner function is 2x plus 1. Our second inner function is sine of x. And then our outer function is x squared. All right, so then we're going to need to take the derivative of all three of these functions. Right, so the derivative of our first inner function is just 2. The derivative of our second inner function is our first taste of chain rule, right? So derivative of our second inner function, when we do it in our final problem, we're going to need to take the derivative of our second inner function with the baby and then times it by the derivative of our first inner function. So we'll get to that. So the derivative of our second inner function is cosine x. And then the derivative of our outer function is just 2x. So now, to find h prime of x, we need to take the derivative of our outer function, right, which is 2x. And instead of x, we're going to put our inner function. So instead of x, we're putting our inner function, but keeping in mind that our inner function has an inner function of its own. right? So our inner function is sine x, but instead of x, we still have this 2x plus 1. Right? Next, we need to multiply it by the derivative of our inner function, which in this case right now is the sine. So we'll multiply it by our inner second function, which is sine, the derivative of our inner second function, sorry, which is cosine. And instead of x, we're going to put in our first inner function. So cosine of 2x plus 1. And then finally, we can put in the derivative of our outer function, of our most inner function, which was 2. Okay, so we have 2 times sine 2x plus 1 cosine 2x plus 1 times 2, which we can rewrite as just 4 cosine 2x plus 1 sine 2x plus 1. All right, so what I want you all to do is work on the right side problems on your own to try to figure out what the derivatives of f of x, h of x, and capital G of x would be.